Okay, so this will be part 2 of this sample problem number 2, all about the truss system. Since we already managed to solve for P sub GF, what I'm going to do next is to solve for P sub CD. And the reason for that is because if I'm going to use the summation of moments here at point G, these two will cancel out because it's going to this pivot point. And the only forces that will tend to rotate the structure is this 140 kilonewtons for that's point F here at point F, and this reaction force at point E, 140 kilonewtons going up, and last but not least also P sub CD. Okay. So we have three forces here that tends to rotate the structure. And let's do that summation of moments here at point G. So summation of moments here at point G, clockwise is positive, m sub G is equals to 0. So if this is the pivot point, P sub GD is cancelled out, P sub GF is also cancelled out. So we have here 140 kilonewtons. From point G all the way to point F is 6 meters. So it's going to rotate clockwise, so it's positive. 140 kilonewtons multiplied by the perpendicular distance equals to 6 meters. Then we have here 140 kilonewtons going to rotate counterclockwise, so it's negative. So 140 kilonewtons multiplied by, so that's 6 and 6, so 12. And we have this also, P sub CD. It has both x and y components. So I'm just going to draw it here. So if this is the resultant, P sub CD, so it has an angle. So this one is for the x component, and this one is also for the y component. It has an angle. Okay, it has an angle. So let's look at here in our free body diagram what would be the slope. So the length of this one is 6 meters. So this one is 6. And the height of this structure, CD, and then somewhere here, we just need to look for the difference between 6 meters and 4 meters. So this one is 2, right? So getting the lowest term, that is basically 1/3. So let's try to draw it here. So if this is 2 over 2 and 6, we can just simply get the lowest term, divisible by 2. This one is 1, and 6 divided 2 is simply 3. And then get the hypotenuse by utilizing Pythagorean theorem. So 3 squared is 9, and then 1 squared is 1. So this one is square root of 10. So this one will be the data that we're going to use. Okay. So what would be the forces that would tend to rotate the structure? We have for both y and x component. Okay. So for let's start with the x component. The perpendicular distance would be this 4 meters because this one is the x component. Okay, that would be the x component. So the perpendicular distance from G to this force acting at the horizontal axis is 4 meters. So the rotation is counterclockwise, so negative. P sub CD multiplied by the slope. What would be the slope? That is simply 3 over the hypotenuse, which is square root of 10. So 3 over square root of 10 multiplied by the perpendicular distance, which is equivalent to 4. It's equivalent to 4. And for the y component, we have what would be the perpendicular distance is equivalent to 6, because from G all the way to this portion, this is the y component of P sub CD. So it's going to rotate counterclockwise, so it's still negative. So minus P sub CD multiplied by the slope, which is 1 over 10. 1 over square root of 10, sorry. And then multiplied by the perpendicular distance equivalent to 6. Yeah. And from here on, it's all about algebra. We're just going to simplify everything. And upon doing that, let's try to simplify first the whole numbers. So this one is basically, if we're going to simplify that, this one is equivalent to negative 840. This one is negative 840 kilonewton meter, because the unit of 6 and 12 is in meter, so that's why we have kilonewton meter. And then for this one, all we need to do is to simplify the slope and the distance. So minus P sub CD, then we can just simply multiply 4 to 3, so that should be 12. 4 times 3 is 12 over square root of 10 minus P sub CD, then 6 multiplied by 1 is simply 6 divided by square root of 10. So that should be 6 over square root of 10. Okay. So upon doing that, let's go at this portion on top. I'm just going to delete and erase some of this so that we can have some space. Okay, going like this. And let's try to solve this algebraically. So I'm going to transpose P sub CD, both of this P sub CD to the left. So upon simplification, P sub CD, the slope 12 over square root of 10, so plus P sub CD 6 over square root of 10 equals to negative 840 kilonewton meter. And the next one is to simply factor out P sub CD. I'm just going to factor that one. And upon doing that, it becomes like this. It's all about algebra. P sub CD, then I'm going to use the bracket. 12 over square root of 10 plus 6 over square root of 10 is equals to negative 840 kilonewton meter. Then dividing both sides by this, it would become P sub CD is equals to negative 840 kilonewton meter divided by this whole. 12 over square root of 10 plus 6 over square root of 10. So upon simplification, P sub CD is equals to, that's approximately about negative 147, negative 147.57 kilonewton, because the unit of here on the denominator is in meters. Okay, the unit for both of that is meters, so cancel the meters, the remaining unit is kilonewton, so that's why it's called kilonewton. And our initial assumption for P sub CD is tension. Okay, that's tension. We have a negative answer, means to say that our initial assumption here is wrong, so we're going to change that into compression. So P sub CD is equals to 147.57 kilonewtons in compression. So we managed to solve for P sub CD. And the remaining force that we need to solve is simply for P sub GD. So this one is the simplest one to solve. I'm just going to erase again so that we can have some space. Just going to leave some space for this whiteboard because it has this amount of space. So we already managed to solve for this one, that's checked. and P sub GF is also checked. And the remaining force that we need to solve is simply P sub GD. So from here on, we can just simply use the summation of forces along the y-axis, because we already managed to solve two of the unknowns, which is P sub GF and P sub CD. So summation of forces along the vertical axis going up is positive. Sub y is equals to 0. We have what would be the value for P sub GF, that is along the x-axis, so we can just simply neglect that. So we have negative 140 kilonewtons going down, and then we have positive 140 kilonewtons going up. So we can just simply cancel that one. We have P sub CD. We have P sub CD was equals to going down. So this one is going down 147.57 kilonewtons. So since it is going down, it's negative 147.57 kilonewtons multiplied by the slope. What is the slope again? This one is 1 and then 3 and then square root of 10. So that should be 1 over square root of 10. Okay. Because we need only the y component. And we have P sub GD. Let's assume that it is in tension. So that should be minus P sub GD. And then the question here is, what would be the slope? Now the slope for this one, I'm just going to simply draw it here momentarily. So if this is the resultant, P sub GD, we have here for the y and for the x. And for the vertical distance is about 4. And for the horizontal is about 6. And then getting the lowest term, let's draw the right triangle. Looks like this. Divisible by 2. So this one is 2. And 6 divided by 2 is simply 3. So that is 9 plus 4. So square root of 13. Yeah. So this is 3 squared plus 2 squared. So 9 plus 4 is equals to 13. So that's why we are going to use for the y component 2 over square root of 13. 2 over square root of 13. I'm just going to delete this. I'm just going to erase so that we can have space. So upon clearing that way out, we just need to solve for P sub GD by transposing it to the other side. So P sub GD, 2 over square root of 13. So this one is simply cancelled out, is equals to negative 147.57 kilonewtons. I'm just going to retain first the unit so that I can save some space. Square root of 10. Dividing both sides by this, P sub GD is equals to negative 147.57 kilonewtons. It's understandable. 1 over square root of 10 divided by 2 over square root of 13. So P sub GD is equivalent to, the answer for that is negative. So that should be negative 84.13. 84.13 kilonewtons. So our initial assumption is in tension. So that's why we're going to change this direction of the arrow and the opposite direction. So that should be in compression. So P sub GD is equals to 84.13 kilonewtons in compression. So this one is the internal force acting at member GD. And part 3 of this sample problem will be for solving the cross-sectional areas.